Hear me okay? Yeah, that sounds good. All right. So was anyone not in the 15-minute version of this I did yesterday? Okay, so a few of you weren't. All right. So the idea was I did a 15-minute version yesterday to the full crowd in the middle of the keynote sequence. And then this is the hour-long version where it's basically the same structure, just go into much more detail about the different stages and the different things about how to speed up innovation. And hopefully we'll finish up in about an hour and have some time for Q&A afterwards. So what is driving innovation? And the way I think about it is the old world of IT, the things that you built were about managing the number of employees you had, managing your supply chain. Your sales channels were indirect, physical shops and things like that. And you did marketing analytics on TV and on print ads. So that's the old world. The new world, everything got a lot more connected. So we've got employees, you're building mobile apps for them. You've got a much more detailed supply chain instrumentation, online sales and delivery. So now you're not just tracking sales outlets, you're tracking every customer you've ever interacted with. You're tracking everything you've ever made via IoT, rather than putting a bunch of things in a box and hoping you never see them again. And online marketing means that your social media presence has to be tracked. You should be able to respond in minutes to some big blow up about your brand in public, right? You don't have time to, you're not just putting out an advert and hoping that people see it. So if we apply this to particular industry, let's look at travel. You know, there's operations maintenance and travel agents. Those are the things that are different that we were managing in the old world. And in the new world of travel IT, there's a lot of operation maintenance on planes and routing optimization, things like that. The travel agents went online, direct bookings. You start IoT connecting all the things that you're managing, maybe baggage tracking or things like that. So you can see, you can take this sort of pattern and apply it to whatever industry you're in and see what does this look like? What are the new things you're trying to manage? And the point about this is you have new needs. You're trying to personalize the customer experience. You're building analytics about what your customers are seeing and hearing and how you're interacting with them. You're building new channels that go directly to the customer. And there is just vastly more things. It's not just a few more things, but the scope of the IT footprint for this can be thousands of times bigger than the things that you had in the old world. So that you're just, everything you've ever made, every customer you've ever touched, you're building databases and you've got data flowing about them continuously. So what we've been doing at AWS and what I've been doing as I go around the world talking to customers is basically trying to unblock this innovation so that customers can iterate more quickly and get things done and get through this transformation. And you can call it digital transformation. That's a bit of a buzzword, but kind of you see what I mean. These are the things that apply across many industries. So there's 4 different things that I think I see repeated over and over again that people are finding that blocks their innovation. One is the culture, and then there's the skills, the organization, and then the risk profile and how finance and board level concerns work. So we'll go through these in turn. So leadership systems, if you've got centralized decision making that's slow, there's a lack of trust, inflexible policies and processes, this is just going to slow you down. And the companies that have figured out how to get through this are the ones that are able to innovate quickly. Got a few, some good advice here. If you're just trying to get moved to cloud, Ahead in the Cloud by Stephen Orban is a really good book. I wrote one of the forwards in this book. There are actually several forwards. Interesting. That's applause for the book, obviously. And Andy Jassy wrote one, and Mark Schwartz wrote one of the forwards. And Mark Schwartz has also written a few really good books himself, A Seat at the Table. There's another one called The Art of Business Value that he wrote before that. And coming soon, War and Peace and IT, which is released this month. A Seat at the Table is about how to be an agile CIO. It talks through all of the ways, all the best practices that everyone says about how CIOs should work and shows that they're rooted in a waterfall model that's too slow, that doesn't work in the modern way. And this explains a new way of thinking about how a CIO should be working. War and Peace in IT is for everyone else who's trying to get the CIO to do something and trying to, it's for the CEO and the CFO and the CMO, whatever. It's for the rest of the executives to work out, this is what you should be expecting IT to do for you. And that's the point of War and Peace in IT. He's a very entertaining writer and speaker. Should definitely, if you see him around, really worth seeing. The books are actually quite amusingly written, and you might sit there giggling at a business book, right? It's got some good stuff in it. War and Peace in IT has got lots of Napoleonic references in it that gives it a whole structure. So I'm going to talk a bit about culture. This is actually a quote from Antoine de Saint-Exupéry. Anyway, I should learn how to pronounce that name at some point. But this is a quote from the Netflix culture deck it's one of Reed Hastings' favorite quotes. If you want to build a ship, don't drum up people to gather wood, divide the work, and give orders. Teach them to yearn for the vast and endless sea. Get out of their way. They build a better boat than the one you had in mind, right? That's the principle. And this is about basically purpose-driven management. We set out really clearly, this is the purpose of this company. This is why we are here. Netflix's case, build a global TV station, right, that connects directly to customers. That's pretty much it. That's, the TVs and movies and whatever. It's a certain type of TV station, but it's really the first global TV station. They launched simultaneously in every country. No one else has ever really done that before. So you get out of the way and you figure it out. So if we look at another culture, Nordstrom has this interesting culture deck, and they said it boils down to one thing, which I found pretty insightful. Use good judgment in all situations as the root of pretty much everything. And it's a very distilled idea that, in fact, I think works really well. If we look at the actual Netflix culture deck, they have these seven aspects of their culture. The first one basically says that the culture deck is really important. When they hire people, we talk about it, everyone's measured against it, and you actually have to live this culture or you'll get kicked out, right? You have to basically be able to show that you're aligning with all these things. But this is a culture aimed at a company that wants to be the first people to do anything. They want to be use their velocity and their ability to innovate as a competitive weapon in a market where initially they were a very small company with very big competitors. Basically, the only thing you can do if you're a very small company with big competitors is be extremely agile, right? And so Netflix was able to run rings around Blockbuster back a decade or so ago. It's currently running rings around most of Beverly Hills and Hollywood with the way they're making new content. They just don't play by the normal rules. They will be moving faster than you can track them. And this culture is built to reinforce that for a company with a very singular purpose. Right? They are focused on being that global TV station and nothing else. It's not even a sports station. It's not a selection of stations. It's basically a single brand thing, right? And that focus on doing one thing is a really powerful thing. But again, this is culture that doesn't apply to most large enterprises. They do too many different things. They're not trying to be the first people to do everything in their space. So copying Netflix culture, I say, is good if you're a startup. Right? If you're a startup or a really small company, you're just trying to get one thing out to market, there's a lot you can learn from Netflix about the focus and the way that they did that. But if we look at the Amazon culture, Amazon now has, I forget what the latest number is, but it's somewhere between 650, 700,000 people in almost every country in the world doing almost everything. All right? So it's an incredibly diverse company. How does Amazon manage to tie together this incredibly large, diverse organization? And it's by using these leadership principles, and they're different to the Netflix ones, and they're a different kind of principle. So again, these are used for hiring, promotions, reviews. These phrases crop up in internal documents all the time. It's how you justify what you're currently doing by saying, oh, I'm inventing and simplifying today. That's what whatever I'm working on, or I'm diving deep, or I'm doing this to earn trust. Those words, when you say them within Amazon, they resonate. People understand, okay, I'm aligning with a leadership principle to justify what I'm doing. And what this does is it gathers together an incredibly diverse organization in a series of principles. And really the principle is that these are the things we care about. These are the operating behaviors we want from people. And that's, again, this is much more relevant to large enterprises because you're trying to gather together an organization and have a common set of principles and language for talking about them. So effective large-scale enterprise cultures should look something like this. So just to summarize on culture, I think culture should be intentional. If you don't just make the culture a very strong part of what you're doing, then you end up with a fractured culture. You tend to see this when you accumulate companies, right? And the companies all have a different culture. You get sort of a warring factions, warring tribes culture, right? That's the default if you aren't intentional. You will end up with warring tribes. The culture needs to be appropriate. If you're a startup, look at Netflix really hard, see what you can copy. If you're a big enterprise, look at what Amazon's done and try to copy that. But I think a lot of these cultures come down to judgment. And if you don't have good judgment, that means that you can't expect people to behave in ways that are defensible, right? If you put somebody in a situation where you give them all the context they need and enough time to make a decision, they should make a defensible decision that shows good judgment, right? If you don't see that good judgment, it means that they're optimizing for a personal gain, or they're optimizing for something that, or you didn't give them enough context or whatever. There's other problems, right? But the idea that you should be exercising your judgment all the time is a powerful way of thinking about culture. All right, that's quite a bit about culture. I'm going to talk about skills. Particularly with cloud migrations, people keep saying, well, I can't find all the people that understand cloud, as if cloud was a really difficult and hard thing to understand. Well, it turns out two-person startups can figure out how to use cloud, so why can't a 100,000-person enterprise figure out how to use it? It's actually, all you need is a web browser and some time. That's it. You don't have to go and get access to a data center like, if you think about what it took to become say, a Cisco certified engineer or a VMware certified engineer, you had to actually have hands-on on very expensive equipment somewhere to do that. The very expensive equipment for the cloud is a web browser and the console. And you can create a globally distributed architecture at huge scale as long as you turn it off really quickly. It won't cost too much, right? So you basically can experiment and learn with almost no friction for cloud. And so the real question is, how do you motivate people to want to do that? And one of the things is, well, we sent everyone on training classes, and then we told them to take the course, but they weren't really motivated about it. I hear that from people and says, well, what did they get once they finished? Because they're now more valuable engineers. They're trained. They're cloud engineers. You'd pay more to hire a cloud engineer than a regular engineer. Yeah, well, of course we would. Well, so why aren't you paying the people you just trained more? Right? You've got to think about, if you set it up so that everyone knows that once you've been through the training, you get certified, you get it could be even a fairly small bump in salary, but it's at least a thank you that incents people to go through it. And now you're creating a systemic incentive for people to learn the new technology. And it may be, you might be just gamify it or, there's a number or give people some shares or something like that. But there's different ways of doing it, but if you are making your employees more valuable by training them and then not letting them realize that value, they will probably leave and get a higher paid job somewhere else. You're just feeding your neighbor down the road that didn't bother investing in training. So think that through. The Netflix culture was actually created partly by Reed Hastings, but also with Patty McCord, and she was the CTO at Netflix, the Chief Talent Officer. Right? That was actually the CTO role. And this is a really good book. I challenge people to take it to their HR departments and get them to read it, because mostly you will see people's heads exploding, because it is one of the most disruptive ideas in HR that we've ever seen. The ideas in this book are absolutely radical to common HR practices. Really interesting book. Don't expect it to have to suddenly get adopted, but it is interesting for shaking people up. Here's another one. We want to move from having projects where you form a project team to go and spend the next 9 months upgrading SAP or something, and at the end of that, 9 months apparently is a short upgrade, I was told when I used that quote once. Okay, spend 2 years upgrading SAP, and then run away from that project and find something else to work. That sort of project life cycle is actually not very productive. What you want to do is put a team on the ERP system and say, make it slightly better every single day. That's your goal. What did you do for me this week? What did you do for me for this day? Like, I want a program of continuous improvement, and you own this thing, and you own it long term. And that is a very different attitude, right? And you break everything into small improvements, and you get continuous improvement. And then we get the idea that you want to run what you wrote. If you're changing something 10 times a day, you don't have time to explain what you did to someone in operations and have them run it and have them be on call for the change you made, right? That's not going to happen if you're doing many updates a day. You have to run what you wrote. And run what you wrote is a quote from Werner Vogel's from 2006 or so. It was sort of when we were at Netflix in 2010 or so, when we were figuring this out, 2009, 2010, we were trying to copy this from Amazon, and this is kind of our interpretation of what DevOps meant. It was like the engineers were on call for the code they wrote because they were updating it continuously. The only people that could safely change this code were the people that had just deployed it and would modify in the middle of changing it. So that's a very different attitude to having a separate ops organization that does very infrequent, manages an infrequent delivery schedule. But what that does is it reduces tech debt and lock-in because I've always got a development team. If I want to change something, change a dependency on a vendor, that's just another piece of functionality that I'm working through in my development schedule. I don't have to form a new project to change a dependency. All right, that's the big difference, and it means that we're basically managing micro-dependencies rather than getting locked into a delivered system. So the point where at the end of a project is actually when the key is turned in the lock and the real lock-in happens. If a project never ends, you're never really getting to that point where you're locked into a vendor. That makes a big difference. There's a really good book on this, Project to Product, came out last year. And then if you want to get more into DevOps, the DevOps Handbook's probably one of the definitive books on this now. So that's the organization. Let's look at risk and start by looking at finance. Some organizations really don't care that much. They actually prefer expense to capital, but others are very capital intensive, and usually the CFO really wants to capitalize things, and they are very used to capitalizing data centers. So it very much depends on the structure of your org and what business you're in. But when you switch to cloud, you typically switch to expense, and if you do that, if it starts to get material quickly and your CFO wasn't prepared for it, they can actually get pretty bent out of shape, and they can actually slow down the entire cloud migration. We've seen this at some large customers. When their cloud spend got to be a material proportion of their total IT spend, the CFO suddenly got involved and said, hey, what are you doing? Where's my capitalization? All right. So get ahead of that. Make sure you understand when it's happening, and that the CFO understands this is a good thing and has sold it on to the board and the shareholders, that this is a sign of progress, not a problem to your bottom line. Right, because that's how it will be seen if they get caught unawares. Also, if you're capitalizing development and expensing operations, then you've mashed them into one organization. You have to come up with a different way to figure out how to capitalize the code that's being developed by this merged organization. And there are ways of doing that. So if we look at boards, moving up a bit more, boards own risk for a company, right? What a board does is they manage compensation policy, executive succession, and they oversight of finance to make sure that they run an audit committee to make sure the CFO isn't cooking the books, things like that. General risk, things like cyber risk, and overall strategy. You know, are we going on an acquisition spree? Are we going to launch in another country? Relatively high-level strategic moves by a company. And this is what the board is concerned about. And the board members effectively are the custodians of the risks a company is taking in these various areas. It's one way of thinking about it. And all of these affect your ability to innovate. But unfortunately, many of the best practices that boards use reduce innovation. They play it safe. And this is a big issue. So if we look at strategy, everyone says, please be more innovative. And they often talk about Netflix and Amazon and companies like Capital One who have been very innovative in finance. You know, well, they say, please be innovative, but are they really supporting it? So let's look at what these companies do. Let's join the dots on this. It's compensation policy, short-term focus. I'm going to pay you a bonus if the stock price is good this month or this quarter, right? That is a very short-term bonus. and it doesn't play out to the long term. Executive succession, if you hire non-technical people, you basic into management positions, you're blindside. They're running blind. They don't understand the technology. So the point here is technology is now so pervasive in the businesses we run that it's not really an option to be non-technical. It's like hiring somebody at C-level that doesn't understand how to read a balance sheet, doesn't understand how marketing works, doesn't understand how sales works. All executives have to have a general understanding of all of these things to work as a team to run a company, right? There's obviously the CFO is really the specialist, but everyone needs to be able to have a conversation with the CFO. But with technology moving to the center in the strategy of most organizations, you have to have everybody there at least understand how technology works at that level. I'm not saying they have to write code, but they have to understand the basics around technology. The other thing is that a lot of these very innovative companies are founder-led. It's obviously true for Amazon and Netflix. Capital One is still founder-led. It was formed in the early 1990s, I think. And founder-led companies are just much braver. They are more willing to take risks. There is a longer-term mindset in a founder. It's their baby. They want to keep it forever, right? When you get the caretaker CEO put in, appointed by the board, that's when you get a much more short-term view, right? So a lot of the companies, that's what they're actually struggling with. Capitalization issues I mentioned, limiting the types of investment you have, those can be issues. Very risk adverse, in fact, well, no failures. That's absolutely would kill your innovation if you don't allow people to try things and have failures. But they say, but please be more innovative. Right? Even though we're not going to do any of these things, we're going to do everything in the old way, we're going to be more innovative. But what I've got here, these are all of the standard best practices you'll see from a lot of places. So let's kind of do a little thing here. Product team wants to use cloud to make a better product faster. So okay, we're going to go do this. What gets in the way? We're going to climb this ladder. We can't leverage cloud because there's policies and processes that prevent us. We can't change those policies and processes because the org chart, right? They are owned by somebody else, and the org chart's just wrong for the new way we want to work. Like this move to DevOps and this move to product instead of project, it's actually a reorg. In fact, DevOps is a reorg for most organizations. We can't change our org chart because the culture doesn't support it, or our lack of culture. Maybe we've got sort of a warring tribes here. And we can't change the culture because our incentives aren't aligned. The incentives in the company are actually preventing us from getting this done. And you can kind of say that as you get the culture you pay for. If you pay somebody to do something and tell them to do something else, they're going to do the thing they're paid for. So, that's normal behavior, right? So if you want to change culture and you want to get people to change behavior, you've got to set up some kind of incentive for that. Can't change incentives because compensation isn't flexible enough. I can't go and pay those highly paid cloud engineers more just because they got trained. Maybe your HR system doesn't support that. And the boards won't change the policy because these common best practices are seen as low risk. This sort of goes all the way up. So this came from some conversation that I was having with why can't you innovate that went all the way to board level. Right? The actual reason that a cloud adoption was going slowly was that the board didn't understand that what they were doing was actually systematically preventing the company from innovating. So what does it look like for the companies that are innovating and are doing well in this space? So the compensation policy tends to focus a little bit on fewer higher paid staff rather than buying bulk cheap people, and more ownership, like stock. Typically long-term stock options. That's a characteristic of these most successful companies. Executive succession includes some level of technical competence in there. Finance, you're managing the expectations and you're investing in differentiators. This is what's driving people to get out of data centers. That's a huge capital expense, which is not differentiating for almost all companies. You just use a cloud. Stop trying to build a better data center than the people you're competing with. It's not really making a difference. The way to deal with risk is to have small projects with incremental returns. It is much easier to manage. All the failures are small failures. You get to learn from them. You have a very tight learning cycle built around this. And you're really focusing on time to value, which I'll get onto a bit later. And what this really does is you're getting out of the way of innovation, right? You don't get more innovative by hiring a VP of innovation and telling them to get on with it. You get out of the way across the whole company. I was actually at eBay before I joined Netflix, and eBay at that point was thinking, we're getting a bit stale, we need to be more innovative, let's create a research lab. So we created a research lab, and it just caused us and them problems and a whole bunch of other issues. And out of that experience, I went to Netflix, and says everyone's job is to be innovative. There's no research role. There are people that are doing more researchy looking stuff, but it's everyone in the company's job to be innovative and research and understand where the world is going. So these bad practices that are focused on minimizing short-term risk get in the way of strategic innovation. And sometimes you're just going to be, that's the way the board is. That company is really going to find it very hard to innovate, and you'll see them sort of lagging behind everybody else. So if your strategy is to lead a market, then you're not going to do that if you have a very short-term focus. Okay. All right, so what I do see, though, is companies going through 3 stages. So I'm going to talk about this now. The first thing is learn to do simple things really quickly. Get speed figured out. The next one is building these systems at scale that happen, this digital transformation where all of a sudden you're tracking every entity, every product you've ever made is now talking to you as an IoT, those kinds of systems. And then the strategic moves where you're shutting down a data center and moving that out to the cloud, those kinds of things, data center replacement. So what are these metrics? First one I think is time to value. How long does it take between doing some work and that work adding value to a customer, right? And if, there's a lot of organizations where it takes months. If you release code every 6 months or so to a customer, turn on customer features, that's a pretty long time for the work you did to be sitting there as work in progress. Some more agile companies might do it in days, or maybe a week or 2, something like that. That's actually reasonably competitive. But the leading companies are doing it in minutes using continuous delivery. If I make a change to some software, the continuous delivery pipeline just pumps it out, and it's in production a few minutes later or as soon as I want it to be. Because these things take minutes if you do it right. And what's happening here is that people are finally realizing there's no economy of scale in software, so smaller changes are better. Many small changes will be much easier to manage than one big bundled together change. And this is against, lots of the things we learn in business are bundle it together, you get the batching effects, and it's more efficient sometimes to do things in larger clumps. Turns out software is the opposite. It's much more efficient to do lots of individual changes. So what you want is an automated continuous delivery pipeline using tagging, feature flags, and A/B tests to control these features as they roll out, and very rapid, cheap builds. So if you're currently, somebody said, this is all great, but my Java monolith takes 11 hours to build every time we make a change. So we have to kind of do that once a week or something. I go, okay. So why don't you break it into microservices and rewrite it in Go? Because Go only takes a few seconds to build. And it really is, this is hours to seconds. So a lot of developer tooling. Even if breaking a monolith into smaller chunks, you'll get a faster build time. And the other thing is, if you're changing one small thing at a time, it's easier to tell if it broke, it's easier to roll back to the previous version, and easier to measure that time to value, because it's one small piece of value is added, and you can measure those two, the commit and the deploy. If you've got a whole bundle of commits over months going into a deploy, it's much fuzzier and harder to measure. So then you want to decouple the new code from the new feature, incrementally change the system with lots of safe updates, and then a marketing launch is a big turn-on of the feature that you've already tested with a few people to make sure it works okay, and it is actually a positive benefit. So small changes are less risk, faster problem detection, faster repair, less work in progress, less time merging changes, happier developers because I change the world every day. That makes people happy. Now, making a change that I don't know when it will ever reach a customer is not going to make you feel good. And you get faster flow. So how do we get there? First is measure across all of your teams what your actual time to value is. Just automate the collection and reporting of commit to deploy. Then learn to do small things quickly. Don't get bogged down speeding up everything. Measure the cost per deploy. like build and test costs. You want to reduce the dollar cost of each deploy and the amount of time it takes. Reduce the number of tickets. You want really one tracking ticket that's automatically updated to record the deploy happened. That's pretty much state of the art. That's what Netflix has been doing for like 6 or 7 years. No meetings. Right? You just deploy. I mean, you can have meetings, but they're not the gate for a deploy. Right? That's the way that these fast companies work. This is how Capital One and Netflix and Amazon and those companies work. All right, a few interesting books. This has been out for a few years. Lean Enterprise, lots of great advice here, but the core of this is the idea of hypothesis-driven development. Every piece of code you deploy is a hypothesis. Will this make the product better is the hypothesis you're testing, and if it doesn't, you remove that feature. Right? That's the key piece here. So Barry is one of the authors of that. This is a book he came out with much more recently, just in the last few months, called Unlearn. Let go of past success to achieve extraordinary results. There's a lot of unlearning needed in enterprise. Principles of Flow. This is a more theoretical book, a lot of queuing theory in here, but it's the basis for why lots of small changes actually will give you better overall change velocity. And then project to product already mentioned. And really, one of the things that slows a lot of companies down is they have all these project managers saying, hey, what do you mean there's no projects? What do I do? And you go, bye-bye? You know, that's a retrain, try to find something else to do. At least if you're trying to make this transition, stop hiring more project managers. Like, let them find other jobs and gradually, you know, redeploy them. But these companies that are doing this fast have really, there are a few places where you do need project management, but it isn't used to deliver everything, right? That's the big change. And unfortunately, the project managers will usually, if they're in control, they will slow down your migration, right?
Is that Gene Kim from your Phoenix project?
Yeah. Forward by Gene Kim. Gene is most of these books are published by IT Revolution, which is Gene Kim's publishing house, which publishes the Phoenix Project and the Mark Schwartz books and Project to Project as well. And he's also on this one. We see the same authors coming by every time, right? Accelerate is actually survey data showing that if you get this low latency time to value stuff right, it actually works, and they correlate with profitability and stock price and other things that people care about, as well as the ability to get more stuff done. Companies are more competitive. And what they did was, out of the survey data, they went and they looked and they formed clusters. And they found the clusters of slow companies and clusters of fast companies. And the fast companies, it wasn't that they were big or small or in different markets. In the same markets, across all different sizes, government departments, there were fast ones, there were slow ones. So what was the difference? It means that some people were doing things in months and other people were doing it in hours. That's kind of what that 440 times looks like. 46 times more frequent deployments, 440 times lead time for commit to deploy. That's the time to value that I keep going on about. 170 times faster recovery from downtime and 5 times lower rate of failure over the whole thing, over time. And then they did an update, and they said there's now a super elite group that's doing everything in minutes. And they're 2,500 times fast. The old group is still running at the same speed because they didn't change in the year. But the fast group, there's now a new cluster emerging of people who are really deploying in minutes. And again, much more reactive. So, you know, this is an excellent book to go read, and it will sort of show you, like, you can figure out, use it to baseline where you are and where you need to be. So what we're trying to do here is learn to do simple things quickly to unblock innovation, avoid complex one-size-fits-all processes, and build the new best IT architecture. And again, if you have a central team of IT architects, they will define an architecture, and by the time they've finished defining it, it'll be obsolete. And you'll spend so long trying to build it that you will actually not spend enough time deploying. So it's one of the anti-patterns I've seen of companies having trouble migrating to cloud is they have a group of IT architects controlling everything. And the best architecture now is the one that's designed to evolve. It's minimalist, it's messy, it's actually inconsistent, but it has strong guardrails. It's like the things that have to have are security, scalability, and availability, but I don't have to define what language you write it in, which framework you use, all these other things, right? But you have to say, whatever you do, it has to be scalable, available, and secure, right? And those much easier to measure. You've got very simple things to measure against. And you really want to support low latency continuous delivery. So that's speed. If we look at scale, the thing here, we've got distributed optimized capacity. What am I talking about? Highly scaled applications that are distributed across the cloud, cost optimized, very high utilization, many times higher than your data center systems. In your data center, it's hard to get higher than 10 or 20% busy with all the extra off-peak time that you've got in your systems. Cloud, you turn machines off and stop paying for them when you go off-peak. And a cloud-native architecture. These are the principles for cloud-native. You pay a month after you use the resources instead of paying years before, because like the way data centers work. It's self-service, API-driven, no waiting. Globally distributed by default. We've got 21 regions running now. Cross-zone and cross-region availability models. Again, very high utilization, and your code deployments happen by deploying new machines, not updating existing machines. Right, those are the patterns. Here's a couple of applications of that. Local one, Qantas, they have their flight route planning is running as a large-scale application in AWS. And EasyJet have these times where they're during holidays or they're doing special promotions, European low-cost carrier, 900,000 bookings in an hour, right? And most of the time, their booking rate's a fraction of that. You want to be able to scale up and down and have a really high utilization system. You don't quite know how high your peak is going to be if you're going to have some kind of flash sale sort of incoming traffic. You can easily build a cloud-based system that will go as high as it could possibly need to go, and as soon as that traffic goes away, you turn it back down, or even with something like serverless, the AWS Lambda, it will just use exactly what it needs to use. So that brings up another question that a lot of us are struggling with. There's a whole bunch of move to containers now, but there's also the serverless computing. So I'm going to run through a little analogy to try and explain my way of thinking about this. Let's say I have a user need to build a spaceship, a toy spaceship, right? And the problem I'm trying to solve is make this model spaceship quickly and cheaply. So how am I going to do that? So a traditional development, design a prototype, carve it from modeling clay, make the molds, produce some injection molded parts, assemble them together, sell that toy. So this is kind of a waterfall-like. You can imagine this taking a few months, right? And there are places where this will break, like the pieces you made molded don't assemble together, so you have to go back and change the design. There's a bunch of iterating in here to get anything done. So what does rapid development look like? I get a big bag of bricks, Lego bricks. I get the instructions, spend a couple of hours on it, maybe. And one of my favorite animations. This is PowerPoint, by the way, and I still don't know how they did that. I paid somebody to make my slides do that. Anyway, I said make a spaceship out of Lego appear, and they came up with this wonderful animation. But I'm just going to play it again because it's so cool. There we go. There we go. Anyway, no idea how you would do that. I would have spent like months trying to make PowerPoint do that. Anyway, this thing lacks fine detail, but it is obviously still the spaceship-shaped thing. Yeah, give it to a kid, they'll play with it roughly the same. It's easy to modify and extend. I can add a piece on the back. I can tinker with it. It's much more fungible. I can tweak it. But it's still a bit bricky, right? So if I take a few of the bricks and I say, you know what, when you look at what Lego does, they do this all the time. They come up with new custom bricks. So we go do this, and we'll make a new custom brick, and then the rest of it's boring, the same old bricks that everyone uses. But we use the new custom brick to make it look nice. And now I've got a new common component that I can use some other time I want to make a spaceship, right? So what's the difference here? Instead of full custom design, we're assembling from parts. It moves from months to hours of work. The custom parts, they're fragile, you have to debug them. Standard parts, they fit together. I have Lego bricks from when I was a kid, rather a long time ago, that will interoperate with modern Lego bricks. They haven't changed. You need to adjust your requirements to fit the patterns available. It's that, Lego toys have to be a certain size. There are multiple of a certain number of bricks, size, width, right? They can't be arbitrary. But the constraints speed up your decision cycles. Right? That's one of the most important things, because you can spend a long time trying to make decisions about what you're doing, but the constraints are how you get to go faster. So if we take this to be containers and serverless as sort of the pattern here, instead of building custom code and services, you're using events and functions. You have very standardized choices for the frameworks, and you combine the building blocks and you build your app, and it really takes hours or a couple of days to build a pretty sophisticated serverless application with Lambda. Now, if parts of that need lower latency, or they're running long-running compute jobs, or you have very predictable high traffic and you want to run it very efficiently, you would then take some part of that rapidly prototype Lambda-based application and code up a container-based solution for it, and have that build a new service, basically. You're effectively constructing a new custom building brick, which you then combine into your whole system, right? So this pattern is one of the things I'm seeing in some of the most agile companies that are getting stuff done incredibly quickly. Particularly, you can use this just as a standard way to rapid prototype almost anything, because it's so fast to get things built. But quite often when you built it, it actually works fine, because this will work at scale, and it costs very little to run. So it's like a double win. But it's a completely different way of thinking about this. And if you haven't tried building serverless apps, this might sound like a bit of magic, right? How could it possibly be like 10 times or 100 times faster to write something that costs less to run and, and still works at all, right? It's a bit confusing. But if you think about it in terms of these Lego bricks are out there and you're still custom making stuff, right? You can assemble things out of those standard components. All right, so just to wrap up, final section here, looking at data center migration. This is a travel company, and their plan is to close all 20 of their data centers by 2023, enhance 80% of customer interactions with AI, and train all their engineers on AWS. So TUI, their first thing they did, it's a European company, they moved a selling platform that was moving billions of euros of business. They got a few staff trained, moved some environments. Their infrastructure availability went up. This is looking good, the first migration. And then built a landing zone, used this first project to figure out how to do it and how to scale it out. And now they've got another 600 applications that they're working on, 550 databases, 22,000 cores of compute. So this is their plan to migrate everything out of there. And this isn't a unique experience. We have lots of companies doing this. For example, Expedia, I've spent quite a bit of time working with Expedia. This is their plan, to get out of the data center, migrate everything over. Ryanair and Korean. So these airlines need to work. I mean, I fly all over the world. I need airlines to work. I'm very invested in the success of these particular customers at a personal level. Actually, flying Ryanair later I've got to get from Budapest to Barcelona, and there's only one direct flight, so I'm flying Ryanair. Anyway. And then we've got companies like Volkswagen that a few weeks ago announced the AWS Volkswagen Industrial Cloud Partnership. This is for, I think there were something like 22,000 locations that this will affect. It's an enormous rollout. It's the entire supply chain of Volkswagen globally, and all their manufacturing facilities and all of their outlets, all their places, doing what is the architecture for moving all of that to cloud. This isn't even just like a few data centers. This is manufacturing, industrial capacity that they're moving over. Huge project. The idea of this is that the platform that gets built for this will be shared. Other people could use it. Other car manufacturers or other large-scale manufacturing companies would be able to use elements of this. So kind of we're creating some new building blocks, and we're using Volkswagen as a leading customer to help explain to AWS, how do you do that? And if we can do this for Volkswagen, then we can do it for all the other companies that say, hey, I'm kind of that big and complicated. We can do that large-scale manufacturing. It's a big, ambitious project, but we've done this kind of thing before with other companies in other markets, so I think this is interesting. So these migrations are underway for a lot of business and safety-critical workloads now. And travel, finance, healthcare, manufacturing, this is going on. And they need to be resilient because these are critical workloads. And we need to move from disaster recovery, which is the way people have been doing it in the past. There's a bit of chaos engineering where Netflix has been doing this. A few people have been working on sort of attacking systems to prove that they're resilient. But in the future, we want to just build fully resilient critical systems that have all this stuff built in by default. Right now, chaos engineering is sort of there. It's being custom built by everybody independently in some sense. We need to get to systems that have this kind of idea built into them. This is a history of chaos engineering. It actually started at Amazon. There's a guy called Jesse Robbins who had on his business card, the master of disaster. He'd go around turning off data centers for the Amazon website. And he simulated one being on fire once because he's actually a reserve fireman. And he said, well, if this data center was, let's say this rack caught fire, what would happen? And he shut down everything in the data center in the sequence that simulated a fire, right? And all these kinds of cool things. We learned a lot from that. At Netflix, a guy called Greg Orzel, that's his Twitter handle, the Chaos Simian, built the really first version. It was the first thing we deployed to AWS was the Chaos Monkey, and we were using it to enforce people to write auto-scaled stateless services. Because if you didn't, the Chaos Monkey would shut you down and you'd stay down. If you're auto-scaled, your machine would immediately come back again. And if it was stateless, it would come back again, everything would still work. You wouldn't have lost any data. So that was why we built that. We open sourced it in 2012. I was basically created the Netflix open source program and ran that for a few years. A company called Gremlin is a guy who worked at Amazon and then worked at Netflix and founded Gremlin. They're sort of productizing this from a startup point of view. Netflix made a book about this. There's some more open source projects, and there's more startups now getting into this space. So this is becoming a little mini industry segment of its own. This is the book Netflix built, Netflix released, and the way to think about this is there's these 4 different layers in your system. There's the infrastructure itself. You want to be able to inject failure to make sure that you know how that behaves. You need to be able to switch traffic between systems. So you need to have 2 copies of your data, and if one database breaks, switch the traffic to the other one. That's what I mean by the switching layer, switching and data replication. Your application code has to just not fall over when it sees something strange, right? There's a lot of testing needed there, but you want to feed bad data in, feed unusual conditions in, and have it not collapse. And then you need to train the people. We call this game days. You have to exercise the people so they know what to do in a failure. And my normal explanation here is, like, if the fire alarms went off now, we'd all know how to get out of the building without taking the elevators, right? That's the standard fire alarm training. Everyone in the world knows that. That is the kind of game day training. Every now and again, at work, everyone has to do a test thing where you go stand in the parking lot until they can let you back in, right? That is the equivalent of a game day. Who does those game days for infrastructure, right? That's what you need to do. So the chaos engineering team uses tools to do that, runs game days, but there's also security engineering, and it's usually they call it the red team, where the security team are trying to break into your system, and the chaos engineering team are trying to break your system. But they're not just trying to break it, they're trying to prove it can't be broken. And the point here is that you're only as strong as your weakest link, and you have to have these teams to find the weaknesses before they'll take you out, right? If you're not attacking your system in some way, you are vulnerable, and as soon as some other random thing happens, you will collapse. And that's the way that most systems end up getting built nowadays. We're trying to move on from that. And this is a systems thinking problem. It's lack of safety margins. You want to build in safety margins to absorb failures. And when you're analyzing these things, it isn't usually component or human error. Component human errors should never take out a system that has safety margin built in. The margin is there to absorb the component failures and the human errors, right? That's the way you build these things. So what you really want to end up with is experienced staff that know what to do in failures. They've practiced it. They've got robust applications, a dependable switching fabric, and redundant service foundation. And cloud gives you the automation for building chaos engineering. This is why chaos engineering has appeared now. We've got API-driven infrastructure that is incredibly, our ability to control what's going on is just vastly better than it was in the data center. So we can actually do this automatically now. And as they migrate to cloud, these sort of fragile manual disaster recovery process, I ask most people to say maybe once a year you test your disaster recovery, and it's a kind of a fraught thing and everyone gets freaked out over it, and once it's over with, everyone gets happy, okay, fine, we don't need to play with that anymore. You should be running this stuff continuously and standardized and automated and productized. So it's going to move from this scary annual experience to an automatic, continuously tested resilience. And there's some people working on this. There's some startups. There's some work we're doing at AWS. And we're trying to help some of our most critical customers get to this step so that they are testing for resilience all the time rather than doing an annual disaster recovery failure. So that's what I've got on my slides. And I'm going to change gear a little bit and talk a bit about Formula One. This is another customer. From our point of view, we did a deal with them to migrate all their data center to the cloud and do a migration. This is from the AWS website. It's a case study, moving the vast majority of its infrastructure on-premise data centers to AWS, using our machine learning data analytics services, working on race strategies, data tracking systems, broadcast insights, which hopefully you've been watching the races. You see the AWS logo on screen every now and again, through a bunch of different services. And then the idea here is we're trying to reinvent the way that fans and teams experience racing. So make it a more engaging experience for the fans by augmenting the sport with intelligence and new types of analytics. So why is this interesting? Why did AWS do this? Well, this is why. They got 500 million viewers a year, and the Formula One organization owns the single feed TV rights globally. Right? I don't have to negotiate. There's 21 races in a year. I don't have to separately negotiate with each country for each race to get the broadcast rights. It's done centrally. So we're able to do a deal where basically AWS did an advertising deal with Formula One to get on-screen graphics. And it was a 4.5-year deal. So we did half of last season and this season. And so for the next few years, you will see AWS logos on screen. And we didn't sponsor a car because the car we sponsored might crash, right, or not win. But we get to win every time because we're sponsoring the whole sport, which I think is a much better way of doing it. And this was largely aimed at the European market. The US market is less strong on Formula One, but we already have Major League Baseball and some other things that were focused on the US market. So this is part of AWS figuring out a marketing strategy that is also very tied into our technology strategy. It isn't just like buying ads somewhere and sticking them on the wall, right? But since this is amongst the most sports in the world, we can get a lot of leverage from this, and it associates AWS with one of the most interesting sports because it's a technology sport. And there's 3 different areas we're doing this. We have an executive leadership series that runs at some races. We're doing it at a few races this year. We had a prototype one we did last year. And my involvement on this is I'm producing some of the content and presenting at some of those races. Rob's going to be presenting at some of them for Formula One, and Pat Simmons is presenting at the other races. That sets the context for executive sharing of ideas. It's a bit like this conference. You know, this is the executive summit. It's a much smaller event, and it's focused around this particular technology idea. And we'll feature the projects that come out of the collaboration as they're developed. As we work through the different migration projects, we will pull them in and we'll explain how we did those to the executives. So if you want to go to one of these, have a nice chat with your sales rep and see if we can, there's a waiting list for most people want to get to. The first one we're going to do is in Barcelona in a couple of weeks. So what can you learn from it? It's analytics and AI, right? You're leveraging large volumes of data and real-time streams. If you saw Rob's talk, this is what he was talking about, huge amounts of data coming off the cars. Continuous improvement in a very competitive setting. If you think about it, you get the slowest cars are a few % slower than the fastest cars. So if you're a few % off the pace, like if you're 0.5% off the pace, that's the difference between like first place and probably 3rd or 4th or even further down the grid, right? So you get to test every week whether you are still the fastest car or what your position is in a different setting with different environmental constraints. The circuit itself changes. And and the way Formula One works, every team is investing in developing the product. They're making the car stronger. The global logistics of Formula One, they ship a data center between races, and the races are sometimes 1 week apart. Would you like to ship your data center to a different continent or to a different city every week? It's like anybody. But looking at the technology and the way they do that is actually quite, I mean, it's a whole story on its own that I hope I can tell sometime. Real-time strategic decision-making, and really just how do you build a winning team? That's all the people side. Who do you build? So I'm going to just end on one little quiz here. There's a new Netflix show People seen this? The Netflix Drive to Survive show. This is about the 2018 season, last season. They're actually filming another season this year, but it's the backstage view of this sport. And it's actually driving more viewers to Formula One, which is great. Great timing, everything all coming together here. The fact it's just like Netflix and Amazon coming together again is actually just fun. So what can you learn? I'm just going to go through these stories. All right. Who are these people? Do I recognize them? All right. Yeah, so what are the stories here? So Lewis Hamilton won the championship last year. He's, arguably the fastest guy there is right now. I think, I'm trying to remember what it was. It's 20 million pounds a year as he's getting paid now. I think, is that right? Was it 20 million or 40 million a year, or was it 40 million for 2 years? Something like that, 40 million a year. All right, so that's a lot of money, but he wins all the races. Do you have a talent strategy to buy the best person you could possibly find at whatever cost? Because then in your competitive market for whatever you're building, you will then win the race against the other people. That argument sort of happens at CEO level sometimes, right? But doesn't make it all the way down into the developers often. Netflix has that strategy for everyone they hire. Like they want to hire the best people in the world, and they will pay whatever their market value is. No one can copy that, really. But that's the Mercedes strategy. The Gasly, last year he transferred basically into Red Bull. And Red Bull have a strategy of developing drivers. So they're getting really young drivers. They don't have to pay them nearly as much. They're paid well, but they're not paid at the Hamilton's level. And they're developing teams. They have a feeder team, which they use to develop the drivers. And they pick people from the feeder team, which is the Toro Rosso team in this case, and move them up to the main team. So they've got two very young drivers, both very aggressive, with Verstappen and Gasly. And then Lance Stroll, the story with him is his dad's a billionaire, and his dad bought a team. And he moved to that team for 2019. So the story was like this team was going out of business, and his dad came in and was sort of trying to sponsor him. I mean, he's a reasonably fast driver. He's finished in the points in the races and things like that. He's not top tier necessarily, but your talent strategy sometimes is to bring in somebody that brings in something else. There's a deal here. There's a sponsorship deal. There's funding. There's other reasons why. There's other partnership reasons why you might come in with it as part of your talent strategy. So the products thing, last year, I think the Ferrari was probably the fastest car, although Hamilton won more races, actually ended up winning the championship because he's a faster driver, so you can kind of trade that off. The Haas car in the middle is built largely out of parts that they can source from Ferrari, like the maximum amount of parts under the rules that they can get. So it's kind of like that AWS thing, outsource all the parts you can get to AWS. Don't build them yourself. So Haas have a very competitive car, partly because the strategy they have is to insource the best components they can find. And then last year, McLaren were just like terrible. They have lots of money, a fantastic amount of talent, and just didn't put it together and built a terrible car that was horribly slow. And they fired the guy who was running the team halfway through the season and started again for this year. Well, logistics, pit stops are the thing, right? A 2-second pit stop, the cars are stationary for a little over 2 seconds. If you get that right, if you don't get that right, you can lose the race. But the fastest pit stops are when you don't do at all. And what you have here is a picture of Hamilton he came in to go into the pits, changed his mind, cut across the grass and went back out again. So sometimes the fastest way to do something is not do it at all. Everyone else pitted on that lap and he ended up winning. And then finally, it's the Haas team again. In the first race of the season, they were in a really competitive situation, and they came into the pits, and a wheel wasn't put on right, the nut wasn't tightened, and they pulled out of the pits and had to stop half a lap. And then the second car came in, and it happened again. Like they operationally were not set up. They didn't train properly, and they threw away what was going to be their best race result ever. By screwing up the pit signals. Anyway, so that's what I had. And I wanted to bring up Rob, and maybe we can do a bit of Q&A about Formula One or the rest of the things I was talking about. So come on up. Thank you. All right.
Thanks, Adrian. Yeah. My own.
Question? Thanks, that was really good. Rob, I've got a question around the cultural adoption of when you introduce new technology, like you're talking this morning around AI and pit times and making those decisions. How do you go against the clash of strong personalities who go, my decision's better, and how do you build that trust that the system's actually smarter than you are?
Yeah, there's a lot of that in Formula One.
There are no personalities with opinions at all, are there?
I think we've all got egos the size of, the size of this conference centre, which makes it quite difficult. I think it's a real collaborative process, to be honest. That's the key to it. And it resonates a little bit with what Adrian was talking about. I think you've got to take small steps. I don't think you can come in with a wholesale change of trying to do something. But you know, this whole thing really always starts at sea level. It starts at board level, because I think if you don't have the board level that is agile and able to adapt to change, that will never resonate through the rest of the business. The rest of the business just won't get that narrative. So you've got to have that culture of being able to change, being able to adapt. And I think that's you know the beauty of Formula One, if you like. And if you know, I've worked in really successful organisations, you know, dominated for years on end and won one world champion after the next. And then I've worked in less successful organisations that have been in steady decline. And the key difference between the two is that top layer of management who's constantly ready to reinvent. You know, they're ready to adapt. They're agile. They're ready to change. And you know, when you're winning and when you're dominant, when you're winning one world championship after the next, as we did in Ferrari from 2003 to 2006, and it had gone on beyond before that as well, before I got there. The really eye-opening thing for me when I joined was how the senior management were so keen to keep reinventing themselves, and so keen to never ever, you know, rest on their laurels. And I think that's, you know, if you've got that culture within the organisation, then regardless of how big people's egos are, you know, to adopt change is quite easy. You know, when I first went to Williams, I used to ask people, why do you do certain things? You know, you spend the first 3 months observing or whatever, and then the things that don't work right, you know, I would often go and ask people, well, why do you do it like that? And 9 times out of 10, the answer came back, because we've always done it like that. And I would respond, but you haven't answered the question. That's not an answer to the question I asked. And, you know, if you can kind of do it, not in a wholesale way, but you can bring people on board the reasons you want to change, and you do it, you know, in a piece by piece fashion, and I think you can, you know, even with massive egos, you can get things across the line. It's not easy, but you can do it.
Okay, good question.
G'day, Rob. Yeah, I introduced myself yesterday with a tacky Filippo comment. Following on from what you've just said, and going from Ferrari with a ton of cash, going to Williams in a family-owned business, and you've just said egos don't get in the way. The budgetary constraints, did they potentially prohibit you being able to achieve more with Williams, going down the routes and introducing these type of tech that you've now sort of been able to go on and do with F1 and Liberty's backing? Did budget come into any of those potential limitations, as well as the cultural mindset?
Well, I mean, whether you're in Ferrari, Mercedes, or Williams, you're always limited by budget. You know, it's a complete misconception to think that the Mercedes team isn't limited by budget. It is. It's just that they've got a 400 million sterling budget compared to 100 million, but they're still limited in their own special way. Does the budget come into it? Yeah, of course it does. You know, it would be completely wrong to say that it doesn't. So you've got to be smart with your budget, whatever you're doing. But I think that, you know, that there's a critical mass, obviously, of budget, where if you've got below a certain amount, then you can't develop anything, because, you know, it costs Formula One teams something like 60 million just to get out of bed. You know, so just to get out of bed and to go racing, it's costing us about 60 million. And then on top of that, there's a few operational costs. So, you know, even teams that it sounds like a lot of money, 120 million budget or whatever, but if you look at the actual money that's given over to development, it usually ends up being around about 15 to 20 million, which in Formula One terms, with the infrastructure and the pace that the teams have to develop, is not great. However, you know, moving to the technologies that we're talking about now, I think Adrian, you know, made a real key point that going from data server to cloud, if you're clever about it, if you've got your smarts on, then it's actually a more cost-effective solution. It's a faster solution, and there's lots of stuff out there in the realms of technology that you can do. So budget does play some part. I mean, it would be wrong to say it didn't. But if you hold yourself back from innovation, if you don't have the courage to go forward, then that's a much bigger barrier than the budget ever will be.
Good. So comment on that. One of the projects that we're having to get to that Ross Braun talked about a bit at reInvent when he was on stage there was this aerodynamic simulation for the next generation rules, right? And they want to simulate cars following each other around corners. And there's lots of combinations, like you've got all the variations that you'd want to do, because it's a two-body problem, and there's all different offsets. So if you think about simulating one car, that's as much work. Simulating two cars isn't twice as much work, it's whatever, huge combination numbers. So then they say, well, how do you build the compute? Like how big is the supercomputer in the data center that runs the fluid flow calculations, right? That's what they needed to build. And then you go, well, how soon can you get an answer? So the way this kind of workload works in cloud is you create as many clusters as you want in parallel. You create them to be as big as you need them to be to get the answer as soon as you want. And it actually doesn't cost you anymore. Because if you had 100 hours of simulation time you needed to get done, and you can do it in 1 hour on a 100 times bigger machine, if it happens to scale, that actually costs the same. So you get answers that, within the limits of how scalable your workload is, you can run as many copies of it in parallel. You don't have to do it serially. So instead of submitting a job to your data center and waiting for the queue of jobs to come through, you can turn stuff around very quickly. And if you're a team trying to get an answer to, is this aerodynamic tweak going to help, and all the variations, you can get an answer very soon using cloud. And in a data center environment, you're limited by how quickly you can move. But it's actually, the thing is that the cost is the same, because it's sort of an area under the curve problem for how much you spend. And a short spike of load is actually costs the same as a long one, right?
Yeah, it's a great example.
Yeah, we're working on getting that workload done, right? It's a lot of emphasis right now. There's a lot of tuning going on and trying to get all of the simulation work running right. Yeah. Somebody else have a question? Yeah.
Thanks. So you can have petabytes of data in your data lake, and if you're not asking the right questions, it's almost irrelevant. In Formula One, is the difference between high-performing and low-performing teams about what questions they're asking and how you interpret that data, or is it as simple as, well, the car has to be fast?
You got petabytes in the car, haven't you?
Yeah.
How much was it you said was inside each car?
Well, we're taking 40 gig per lap.
40 gig per lap.
Yeah.
Times, 80, 60, 70, 80 laps.
Yeah.
Yeah. There's a fair amount of data.
I think that's the case for any business, isn't it? If you're not asking the right questions of your analysis and analytics, you're not going to be able to progress and to perform. Of course, the output is just the output of Formula One is lap time. The input into the system is car performance, and you need to understand both. I don't know if you saw my keynote this morning. And in order to do that, you need to know what questions you're going to ask of both the output and the input. And that still is why, you've got this, I find it fascinating and quite beautiful. You've got this merger between man and machine. If we're going to use artificial intelligence, it was kind of the message that I gave at the end. You still need the visionary who uses unique human intelligence. And it is unique because we are still more creative than machines, thank God. So, the human still has to ask the question, and then you need to use the technology to be able to answer those questions. But of course, the more intelligent your human being is, and the more experienced he is in that sector, in that domain, the better chance that he's got of asking the right questions. But you know, it comes down to the example I gave before of, you know, working in a dominant organisation, or dominant in Formula One terms, and working in something quite rudderless. You know, the rudderless ones will quite often be asking the wrong questions. They'll be asking the wrong questions of themselves. They'll be looking in the wrong areas. You know, the point is that they don't know what questions to ask, not whether or not the question's right or wrong. They just don't know what questions to ask. And that goes right from board level downwards. So you do have to, you know, it comes to, it's Adrian's point about Netflix, which entirely resonates with Formula One. And, you know, I'm not going to be crass and go into any examples, but you know, Adrian picked a driver there. He picked on a driver which is paid 40 million. But there's plenty of other people who are paid enormous sums of money. But the reason that they're paid enormous sums of money, you know, engineers, technicians, your team principals, the reason why they're paid enormous sums of money is because their extreme talent level in that sector, in that domain, allows them to ask the right questions and allows them to focus on the right things.
So there's, I put up that Lean Enterprise book, Hypothesis-Driven Development. I mean, this is exactly the way this works. And when I joined Netflix in 2007, I found that every single thing they did was a hypothesis test. Like every change they made to the product, and they've been doing that. They'd been doing it for years already. So the whole company is built on the idea that the product manager's job is to think of the right question and think of something testable. The engineering manager's job is to find the most efficient way to test that hypothesis. And there's a data point which actually came out of Microsoft research that if you have 100 ideas and you test them all, a third of them will make the product better, a third will make no difference, and a third will make it worse. But you won't know which third until you've tested all 100. And that roughly felt right, that from my experience there. And sometimes the biggest wins came from something that we almost didn't test, that one person had enough conviction to kind of go, yeah, I want to try this. And that turned into the biggest win that month, right? And some of the things that we thought were absolute shoo-ins made the product worse. And then you get into a big product meeting and they would go, here's the tests that we're doing. Here's the results of the last few tests. Has anyone got a clue why it did that? Like, what the hell's going on? We've got these customers behaving in the ways that were totally unintuitive, and you have to develop a new intuition and figure out, okay, I mean, you know, they're testing. Everyone that uses Netflix as a guinea pig, you're all in different test cells. I can tell you that, right? Everybody that's ever used it is in a different set of test cells, and you're all being used, your fine-grained statistical differences in behavior are feeding them with an enormous amount of data on how to tune that product. But the problem then goes is if you get into a culture where failure isn't tolerated, the fact, you know, you will never do enough tests because you'll only be trying to find the successful ones. You get overly cautious, you don't find those big wins. And that's kind of the problem you get into. You get too cautious, you're not going to throw the net wide enough to find the real wins, and you're not going to have, so the trick here is to figure out how cheaply can you test every possible idea, and right? In Formula One, you've got 1 week, right? What are you going to change by next week that's going to make you slightly faster than the other guys?
Yeah, and I think that's a key point, to be honest, is when you're trying to manage risk around your development, it's never cheap to, you know, we're in a situation where we're putting out product that is not cheap to test, because the only way to go and test it is on the track. And you know, I'm not talking about cheap in terms of, you know, fiscal, I'm talking about cheap in terms of the resource. You've got to take up resource to develop. And so that's always quite a hard balance to throw when hopefully you've got an innovative group who are trying to develop the car, trying to come up with new ideas, and which one do you pick? Because, you know, all of us, from those with the 400 million budget to those with the 80 million budget, they're all resource limited to some level. So where do you pick the wins? But you've got to have, so in order to get that balance right, or somewhere near right, because nobody ever gets it fully right, you've got to have a culture that tolerates failure. So you've got to be able to innovate beyond something that's quite safe. Otherwise, you'll always be in this realm of being mediocre but never excellent, which is rewarded in Formula One. And you know, you've also got to have the backing of the board to be able to do that. And I think if you don't marry those two things together, the system never works.
Okay, Rob, we might call time there. Can we just put our hands together to thank Adrian and Rob for the session this afternoon?
Thanks. And thanks very much.
Thank you.
Yeah.